Hello, and welcome to Relaxing Facts Studio. I'm glad you're here tonight. Wherever you are listening from, you don't need to be anywhere else right now. There is nothing to solve, nothing to decide, nothing waiting for you. Just this moment, just this quiet space. Allow your shoulders to soften. Let your jaw relax. Notice your breathing without trying to change it. Slow, steady, unhurried. Tonight, we're taking a gentle journey, not one that requires effort or attention, but one you can simply drift along with, like floating on calm water under a wide, open sky. Tonight, we're exploring something vast and ancient, something you are already part of, our home galaxy, the Milky Way, a spiral of light and shadow stretching more than 100,000 light-years across, home to hundreds of billions of stars, turning slowly through space, long before humans existed, and long after we are gone. You don't need to imagine it clearly. Just let the idea rest in your mind, soft and distant, like a dream you don't have to follow. The Milky Way has been spinning for over 13 billion years. That number is so large it almost loses meaning. So instead of thinking of time in years, think of it in breaths, one breath after another, an endless, patient rhythm. Our galaxy was not born whole. It grew slowly, piece by piece, from clouds of hydrogen and helium left over from the Big Bang, from smaller galaxies drawn in by gravity, stretched, dissolved, and folded into its structure. Even now, the Milky Way carries the quiet remains of these ancient encounters. Long streams of stars curve across the sky, invisible to the naked eye, but unmistakable to careful instruments. They are the ghosts of galaxies that once traveled alone. Nothing here was rushed. Everything unfolded gradually. Gravity does not hurry. Some stars in the Milky Way are older than the galaxy itself. They formed before the spiral arms fully took shape, before order settled into rotation. These ancient stars drift through the galactic halo, far above and below the disk. Their orbits are tilted and slow. Their light is faint and steady. They contain almost no heavy elements, only the simplest ingredients of the early universe: hydrogen, helium, a trace of lithium. They are like elders, quiet witnesses to a younger cosmos, still shining, still present. Our own solar system is moving too. Right now, as you rest, the Sun is carrying Earth around the center of the Milky Way at more than 500,000 miles per hour. And yet, the journey is so vast that it takes about 225 million years to complete a single orbit, one galactic year. Since the solar system formed, it has completed only about 20 of these slow revolutions. When the first dinosaurs appeared, we were in a completely different region of the galaxy. The stars above you tonight were not always neighbors, and they will not remain so forever. Everything moves. Quietly, endlessly. The Milky Way is still growing. Even now, it gathers material from its surroundings. Wisps of gas drifting in from intergalactic space, small companion galaxies being gently pulled apart. Some of this growth is peaceful. Other times, it leaves scars. The galaxy you live in today is not the same one that existed a billion years ago, and it will not be the same a billion years from now. Change here is slow, but it is constant. From inside the galaxy, it's hard to see its full shape. Dust clouds block our view. Stars overlap and blur together. For a long time, astronomers believed the Milky Way had 4 main spiral arms. More recent observations suggest the structure is more complex. Arms that split, fade, reconnect, patterns that shift over time. The galaxy may not be a neat pinwheel at all. It may be more like a living current of stars, layered, flexible, still forming. Most stars follow calm paths around the center, but a rare few are flung outward at incredible speeds. These are called hypervelocity stars. They are often born in pairs. When such a pair wanders too close to the supermassive black hole at the galaxy's core, gravity makes a choice. One star is captured, the other is thrown free, launched into intergalactic space at millions of miles per hour. A glowing exile, traveling alone into darkness. Even in a system held together by gravity, there are moments of release. Far beyond our galaxy, Andromeda is approaching, a spiral much like our own, visible as a faint smudge in dark skies. It is more than 2 million light-years away, and yet it is moving steadily closer. In about 4.5 billion years, the Milky Way and Andromeda will begin to merge, not in a violent crash, but in a slow, graceful interaction. Stars will almost never collide. Space is far too vast for that. But gravity will reshape everything. Long arcs of stars will stretch outward. The 2 galactic cores will spiral together, and over billions of years, a new, larger galaxy will emerge. Even galaxies have life cycles. Some stars in the Milky Way orbit backward, against the general flow. These stars likely came from elsewhere, born in smaller galaxies that were later absorbed. Their reversed motion is a memory, a quiet record of ancient encounters. The Milky Way has consumed dozens of dwarf galaxies over its lifetime, each one adding stars, adding motion, adding complexity. The galaxy is not pristine. It is a mosaic, built from fragments, stitched together by gravity. Every star carries a chemical signature, a pattern of elements formed at its birth. By studying these patterns, astronomers can trace where stars came from, which formed together, which arrived later. In this way, chemistry becomes a kind of history book, written not in words, but in light. Across the sky, there are delicate ribbons of stars called stellar streams. They arc and curve around the galaxy. These streams are the stretched remains of smaller galaxies and star clusters, pulled apart over time. They are faint, subtle, but they tell a clear story. The Milky Way is warped. Its disk bends gently upward on one side and downward on the other. This warp may be caused by passing galaxies or by uneven distributions of dark matter. From a distance, the galaxy might appear to ripple, like a slow wave frozen in motion. Under a clear, dark sky, you might see a few thousand stars. To the eye, it feels like abundance, but it is only a tiny fraction, about 300,000ths% of the galaxy. Most of the Milky Way is hidden, behind dust, beyond distance, outside human vision. The spiral arms are not solid structures, they are patterns, density waves moving through stars and gas. As gas enters these regions, it compresses. New stars ignite, lighting the arms from within. Our sun drifts through these patterns slowly, in and out, over immense spans of time. The galaxy is not a machine, it is a flow, and it holds together because of something we cannot see: dark matter, an invisible substance that does not emit light, does not reflect it, but exerts gravity. There is far more dark matter than visible matter in the Milky Way. Without it, the galaxy would fly apart. Dark matter forms a vast halo around the galaxy, an unseen framework holding everything in place. At the very center of the Milky Way lies a supermassive black hole, Sagittarius Asterisk. It contains the mass of more than 4 million suns, compressed into a region smaller than Mercury's orbit. We cannot see it directly, but we see its influence. Stars whip around it at incredible speeds, tracing invisible paths. Today it is quiet, but long ago it may have shone like a quasar, bright enough to be seen across the universe. The heart of the galaxy is complex. The central bulge is shaped like a peanut, thick and three-dimensional, formed by the slow buckling of the galaxy's central bar. Nothing here is simple. Nothing is still. Beyond the disk lies the galactic halo, a vast, faint sphere surrounding everything. It contains ancient stars, globular clusters, and most of the galaxy's mass. More than 150 globular clusters orbit the Milky Way, dense spheres of stars, among the oldest objects known. Some are over 12 billion years old. Their stars are tightly bound, moving together. They are survivors from the galaxy's earliest days. As you rest now, all of this continues. Stars orbit, gas drifts, dark matter shapes motion, and you are part of it. Your body is made of elements forged in stars: carbon, oxygen, iron. Long ago, massive stars lived and died so that these elements could exist. You are not separate from the galaxy. You are one of its quiet expressions. There is no need to hold on to these thoughts. Let them pass like distant starlight. If your mind wanders, that's fine. If sleep comes, welcome it. The Milky Way will continue turning, patient, enduring. If you're still awake, that's perfectly fine. If you've drifted in and out of sleep, that's fine too. There is no right way to listen tonight. Just allow the words to move gently around you, like distant wind through tall grass. Earlier, we spoke of the Milky Way as a structure, a vast system of stars and gravity. Now, let's slow even further and explore the quieter life within it. Not the dramatic events, not the collisions or the explosions, but the slow, patient processes that unfold over millions of years. In the galaxy, most stars live calm, uneventful lives. They are born, they shine, and they slowly fade. A typical star spends billions of years fusing hydrogen into helium, steadily, silently,
without drama. Our Sun is one of these stars, middle-aged, stable, predictable. For every bright, massive star that lives fast and dies young, there are countless smaller stars.
Red dwarfs, dim and long-lived. Some red dwarfs will shine for trillions of years, longer than the current age of the universe. They burn their fuel so slowly that time barely touches them. In the far future, when larger stars have faded, these quiet red points of light may be all that remains. The Milky Way is filled with them, invisible to the naked eye, yet making up the majority of its stellar population. Between the stars lies space that is not truly empty. It is filled with thin gas, atoms drifting far apart. In some regions, this gas becomes slightly denser, still emptier than any vacuum on Earth, but dense enough for gravity to begin its work. Over millions of years, these clouds cool, they contract, they fragment. Slowly, gravity pulls material inward until, at the center, pressure and heat ignite a new star. Star birth is not sudden, it is gradual, like sleep. These stellar nurseries glow faintly, not because they are hot, but because young stars illuminate the gas around them. Many stars are born together, clusters of siblings forming from the same cloud. Over time, these clusters drift apart. Stars separate, taking their own paths through the galaxy. The Milky Way is filled with these dispersed families, former neighbors now light years apart. Some stars are not alone. They orbit companions. Binary systems are common, two stars bound together, circling a shared center. Some systems contain 3 stars or 4, complex dances of gravity and motion. Planets often form around these stars, worlds with 2 suns or long, irregular days. We do not know how many planets exist in the Milky Way, but estimates suggest there may be more planets than stars. Rocky worlds, gas giants, frozen bodies drifting in darkness. Most will never host life, but they exist nonetheless, silent, patient. Far from the bright disk, globular clusters move through the halo. Their stars are packed tightly together. In these environments, stars pass close to one another. Gravity reshapes their orbits, exchanges companions. Some stars are ejected, others sink inward. Time moves differently in such crowded places, not faster, but more interactive. Deep within the galaxy, time also leaves its mark in another way. Cosmic rays. High particles moving near the speed of light, born from distant supernovae. They pass through the Milky Way constantly, through stars, through planets, through you. You never notice them, and yet they are everywhere. Magnetic fields thread the galaxy as well, invisible lines guiding charged particles. These fields are weak by Earth standards, but vast in scale. They shape gas clouds, influence star formation, and ripple slowly through the spiral arms. The Milky Way also contains vast bubbles of hot gas, enormous cavities carved by ancient explosions. Some of these bubbles stretch thousands of light years above and below the disk,
evidence of powerful events long past. Even now, the galaxy exhales energy into intergalactic space, a slow breathing you will never hear. Dust plays a quiet role too. Tiny grains of carbon and silicates. They block light, scatter it, cool gas clouds. Without dust, stars could not form easily. Planets would not exist. Dust may seem insignificant, but the galaxy depends on it. Over time, stars change. As fuel runs low, balance shifts. Some stars swell into red giants, their outer layers drifting away. Others collapse into dense remnants, white dwarfs, neutron stars. Neutron stars are incredibly compact. A teaspoon of their matter would weigh billions of tons. They spin rapidly, sometimes hundreds of times per second. As they rotate, beams of radiation sweep through space like cosmic lighthouses. If Earth lies in the path of one of these beams, we detect a pulse, a steady rhythm from deep space. These pulses are so precise they rival atomic clocks. They mark time across the galaxy, even as everything else slowly changes. Some stars collapse even further, becoming black holes. Not all black holes are enormous. Many are only a few times more massive than the Sun. They drift invisibly, silent, undetectable, unless they interact with something nearby. The Milky Way likely contains millions of them, moving quietly among the stars. The galaxy also contains vast regions of silence, areas where star formation has ceased. Gas has been used up, energy has dispersed. These regions are calm, stable, a kind of cosmic rest.
Over billions of years, the Milky Way will slowly exhaust its ability to form new stars. Gas will thin, birth will slow. The galaxy will grow quieter, redder, older. But that time is far away. For now, the Milky Way remains active, balanced between creation and fading. As you lie here, breathing slowly, none of this demands your attention. It unfolds whether you watch or not. You are allowed to rest. Your thoughts can soften. Your awareness can drift. The galaxy will continue its patient turning. Stars will rise and fall. Gas will drift. Gravity will hold. And you can sleep, knowing that everything moves forward without effort from you. We've explored how the Milky Way formed, how it lives and breathes. Now we turn our attention forward, not to tomorrow, not even to the next 1,000 years, but to the deep future, times so distant they feel almost imaginary. The Milky Way will not always look as it does now. Galaxies, like stars, age. In the coming billions of years, star formation will slow. The raw material that feeds new stars will thin out. Clouds of gas will become smaller and more scattered. Fewer stellar nurseries will glow in the spiral arms. The galaxy will gradually dim, not suddenly, not dramatically, but quietly. Bright blue stars will disappear first. They live fast and burn hot. When they are gone, the galaxy's light will soften. What remains will be longer-lived stars, cooler, redder, more subdued. The Milky Way will slowly shift in color, from vibrant whites and blues to gentle ambers and deep reds. In the far future, spiral arms may fade entirely.
The clear structure we recognize today may blur. The galaxy will become smoother, less defined, a vast, aging collection of stars drifting together. Planets will continue their orbits. Many will remain stable for trillions of years. Some worlds will cool completely, their surfaces frozen, atmospheres thinned or lost. Others, orbiting long-lived red dwarfs, may remain warm far longer than Earth ever could. Time stretches differently here, without urgency, without milestones. As stars age, more remnants will accumulate. White dwarfs will outnumber active stars, faint cooling embers of former suns. These stellar remnants will shine weakly, slowly releasing stored heat. Some will drift alone, others will remain bound in ancient systems. Occasionally, two remnants may pass close enough to interact, a brief flare of energy, a short moment of brightness, but such events will be rare. Black holes will persist, unchanging on human timescales. They will drift through the galaxy, sometimes merging, sometimes feeding slowly, but even they will not dominate the sky with light. The Milky Way's core will grow quieter, less active, less luminous. Over immense spans of time, gravitational encounters will continue to reshape the galaxy. Stars will exchange energy. Some will be nudged outward, others will sink inward. Gradually, the galaxy will lose members, stars escaping into intergalactic space, one by one. This process is incredibly slow, so slow it feels like stillness. Eventually, the Milky Way will become more diffuse, less tightly bound. Its outer regions will thin, its halo will stretch. The galaxy will not vanish, but it will relax. Far beyond even that future, the universe itself will change. Expansion will continue. Galaxies will drift farther apart. Light will take longer to cross space. From within the Milky Way, distant galaxies will fade from view, one by one, until the night sky contains only our local stars, and then fewer still. Cosmic isolation will grow, not as loneliness, but as quiet. Within the galaxy, time will feel almost frozen, change measured not in years, but in eons. Eventually, even red dwarfs will exhaust their fuel. After trillions of years, they too will fade. The galaxy will become a collection of dark objects, cold stars, dead planets, black holes. Motion will continue. Gravity never stops working, but light will be rare. If any consciousness were present then, the universe would appear very different, not bright and dynamic, but dim and still. Yet even in that darkness, nothing truly ends. Particles continue to move, quantum processes continue, space itself still exists. The universe does not rush toward silence, it drifts there. And long before any of this matters, you are here, now, breathing. Your place in this vast timeline is brief, and that is not a flaw. It is what makes rest meaningful. You do not need to witness the galaxy's future. It will unfold without effort from you. Your only task tonight is simple. Let go. Let the scale of time soften your thoughts. Let the distance between stars quiet your worries. Nothing is required of you in a universe this patient. As the Milky Way slowly ages across unimaginable spans, you can sleep. Your breathing slows. Your awareness fades. The galaxy continues its gentle motion, unconcerned, steady, and you drift with it.